This investigation is one option to fulfill the requirements of the curriculum expectation SCH 3U B2.3 and the scientific investigation skills A1.5, A1.6. Teachers should consult the relevant MSDS sheets before considering this investigation. Prior to beginning the investigation, teachers are reminded to discuss fire safety procedures with their students, including the location and use of fire extinguisher, any potential dangers associated with this activity, and the need to carefully follow the instructions and example of the teacher. Here are the materials you will need for the investigation. The alkali metals are very reactive and are kept in mineral oil. The stock containers are stored on the shelf with other flammable materials. Take the container of metal off the shelf to the preparation area. This stock container does not leave the teacher preparation area. Pour a small amount of mineral oil into the Petri dish. Label the lid of the dish so you know your sample when you're in the classroom. Now you need a small piece of metal to show how it reacts with the water in the classroom. Your equipment needs to be dry, so dip the forceps and knife into some oil to ensure there is no water. Use the forceps to lift the metal out of the container and place it on the oily tray. This is sodium. Return the metal to the container and move the sample to the Petri dish. Cover the Petri dish with the labeled lid and return the stock container. Take a 1,000 milliliter beaker for the demonstration. Add about 450 milliliters of tap water to this beaker. Add 3 drops of 0.1 molar sodium hydroxide to the water to make it slightly basic. Add a small amount of phenolphthalein to make this water slightly pink. Now, add a few milliliters of vinegar so that the phenolphthalein does not show. This will allow students to see a color change as a hydroxide is produced in the reaction. Check the classroom to make sure it is ready for the demonstration. The overhead is ready and working, eye protection is available, and a safety shield is set up in front of the overhead projector. Ask students close to the overhead projector to move back. The reaction shows that both hydrogen gas and heat are produced. The heat can cause the hydrogen gas to react and explode, expelling the metal out of the beaker. Start the demonstration with lithium metal. Before adding the lithium to the water, show students the lithium metal in the oil. They can observe that it is a shiny metal. At the front of the class, open the container and use a knife to demonstrate that the metal is soft. Tell students that this is also true for sodium and potassium. Start the demonstration to show the reaction with water. The lithium hydroxide has turned the water pink. Add a small amount of vinegar to remove the color. Too much vinegar will ruin the next demonstration. Review the student observations. This will help some students pay closer attention to the rest of the demonstration. After the demonstration with sodium metal, continue with potassium metal. The potassium has no yellow crust, which means it is safe to use. If it has a yellow crust, it may explode when cutting. Potassium is the most reactive metal and most likely to create a flame. A small amount of vinegar is first added to the beaker of water, and then the potassium metal is added to the water surface. Senior students may perform a modified version of this activity. Allow students to use a smaller beaker, 250 milliliters or 400 milliliters, of water and phenolphthalein solution. They must also add a wire mesh to the top of the beaker during the metal-water reaction. Prepare small samples of the alkali metals ahead of time and carry them into the classroom using Petri dishes one for each metal, with sufficient mineral oil to immerse the samples. STAO does not recommend that students work with potassium metal.